Welcome back to today's video lesson on Chemistry Made Easy with Bright Edu. In today's lesson, I'll be teaching on a very important aspect in chemistry, and it is on the IUPAC Nomenclature of Alkanes. So it means that in today's class, I'll be teaching on how to name compounds that are alkanes. Now, it must be noted that compounds that are alkane contains the carbon-carbon single bond. So compounds that are alkane contain the carbon-carbon single bond. So it means that all compounds that are alkane contain single bonds, and alkanes are hydrocarbons. So it means that they contain carbon and hydrogen. So in the course of today's lesson, I'll be teaching on how to name compounds that are alkane, so compounds that are single bonded. Now, it must be noted that the word IUPAC simply means International Union for Pure and Applied Chemistry. So we'll be using the International Union for Pure and Applied Chemistry to name organic compounds, because alkane is an organic compound. So before we start with the rules for naming organic compounds, it must be noted that whenever a particular compound that is organic contains one carbon, we simply call that compound or the parent name to be met. So if it is 2 carbon eth, if it is 3 carbon prop, 4 carbon but, 5 carbon pent, 6 carbon eggs, 7 carbon ept, 8 carbon oct, 9 carbon non, and 10 carbons dec. So it means that all of these important points must be noted. So let's quickly move over to the rules for naming organic compounds. And in today's lesson, we'll be focusing on alkanes. Now, let's quickly move over to the first question. Now, you can see this first question written on the board. So the question is, what is the IUPAC name of this compound? What is the IUPAC name of this compound? It is very easy. First of all, this compound is an alkane. This compound is an alkane. Why is it called an alkane? Because it comprises of single bonds between the carbon atoms. Single bonds between the carbon atoms. Single bonds between the carbon atoms. You can see there, you can see all of the bonds in the compound. So the first rule says, select the longest continuous carbon chain. Now, it must be noted that the longest continuous carbon chain is not always in the horizontal direction. Now, let's check the longest continuous carbon chain. Counting from here to here, let's check how many carbons we have to get. So 1, 2, 3, 4, 5. So I'm having 5 carbon when I counted horizontally. Let's count in this fashion. 1, 2, 3, 4, 5. Now I'm still getting another 5 carbon. Now you can see when I counted horizontally, I got 5 carbon. When I counted in this direction, I got 5 carbon. So it means that either direction I count, we'll still get a 5 carbon compound. Now let's just decide to take the horizontal pattern. So when we do that, when we've selected, it becomes something like this. It becomes something like this. CH3 bonding to CH, bonding to CH2, bonding to CH2, and lastly bonding to CH3 and at carbon 2 bonding to CH3. Now let us select the longest continuous carbon chain. This is the longest continuous carbon chain. If we decide to count in this direction, this would have been the longest continuous carbon chain. But you can see, counting horizontally and counting in this direction, it gave us 5 carbon. Now you can see here now we are having a 5 carbon compound. Recall, what was a 5 carbon compound called? A 5 carbon compound is called a pent. That's as the parent name. So you say pent. And now, since it's an alkane, you simply add the last name, which is ane, it becomes pentane. So it means that the parent name of this compound we are to name is pentane. But looking at this same compound, it has a substituent. Before we go over there, let us name the longest continuous chain. Now, naming the longest continuous chain become pentane. Okay, that's the answer. We've named the longest continuous chain. That's for rule number 2. Name the longest continuous chain. And the longest continuous chain now is pentane, because you can see that when we counted the carbon, we had 5 carbon, and a 5 carbon compound is basically called a pen. So since it's an alkane, you add A and E to the name, become pentane. Now, rule number 3 is to number the longest continuous chain. We are to number the longest continuous chain. You can see that here gave us the parent name of the compound. So let us number the longest continuous chain, okay, of this compound. Now, it must be noted when numbering, you should number in the direction so your substituent in the compound, the branch, the substituent in the compound gets a lower value. For instance, we are to number in this direction from here to here. Let's do that. So let's say here is carbon 1, here is carbon 2, here is carbon 3, here is carbon 4, and here is carbon 5. So you can see we numbered from this direction to this direction. And let us number from this direction to this direction. So let's make here our number 1, 2, 3, 4, and 5. Now, doing this, what becomes the number for the substituent group in both directions? You can see when numbering from this direction, we had 2 for the substituent. When numbering from this direction, we had 4. I said earlier that you should number to the direction so your substituent have a lower value. So numbering from this direction will be the best way to number, not from this direction, because here it gave us a very, very large number, which is 4, which is not correct. So numbering from this direction is the best for this particular compound. So that is for that. So after numbering, we've numbered. So the substituent now was now in the carbon 2 of the longest continuous chain. The substituent was now in the carbon 2 of the longest continuous chain. Now, next point is to identify the substituent. Now, the substituent I'm seeing here is CH3. And what is CH3 called? CH3 is called methyl. CH3 is called methyl. And what is a methyl? A methyl is simply an alkyl group. And how is an alkyl group formed? An alkyl group is formed when one hydrogen is removed from an alkane. Now, this is what I mean by explanation. Let's say this is an alkane. So, for instance, we remove one hydrogen from an alkane, we get an alkyl group. So, let's say this is methane. Methane is the first member of the alkane series. When we remove one hydrogen from methane, we get methyl. And what is the chemical formula of methane? CH4. Removing this minus one hydrogen, we have CH3. So you can see that this substituent is called the methyl group substituent. And the methyl group substituent is at carbon 2 of the longest continuous chain. So how do you name this compound? Very easy. Now we simply first write our parent name for this compound. The parent name is gotten from the numbers of carbon from the longest continuous chain. How many carbon do we have? We have 5 carbons. So the parent name becomes pent. And since the compound is an alkane, it is pentane. And at carbon 2, we had a substituent. And what is that substituent called? The methyl group substituent. So we simply, to be specific, say 2-methyl pentane. But it must be noted that between numbers and letters, we use hyphen to separate them. Okay, this dash sign. Okay, so if when you're writing numbers and letters, when naming organic compound, use hyphen or dash. So it's basically 2-methyl. So 2-methyl pentane. So 2-methyl pentane is the name of this compound. So let's quickly move over to the second question. Now, from the rules given in the first question, let us quickly solve and name this compound? Very easy. First of all, we are to select the longest continuous chain. Now, how do we select the longest continuous chain? Let's count horizontally first. So, carbon 1, carbon 2, carbon 3, carbon 4, carbon 5, carbon 6. So, we have 6 carbon 1, we count like this. So, let's count in this fashion. 1, 2, 3, 4, 5, 6. We are still getting 6 carbon. So, we leave this and leave this. Let's check. From here, 1, 2, 3, 4, 5, 6. 6 carbon. Okay, now you can see counting from different direction, I had 6 carbons. So let's just count in the horizontal fashion, but it is not always in the horizontal fashion. So let's just identify by selecting this particular pattern for naming the compound. Okay, so that is for that. So we've selected the longest continuous chain. Rule 2, after selecting the longest continuous chain, you simply name the longest continuous chain. Now, since it is 6 carbon, what becomes the parent name? Eggs. And it is an alkane, basically it is hexane. After doing that, you simply number the longest continuous chain. That was rule number 3. Recall, I said that numbering the longest continuous chain, you must number in the direction so the substituent should have a lower number. So let's count like this and count like this and see which one has a lower number. So here is 1, here is 2, here is 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. You can see that at counting in this direction, the substituent which is now known, called methyl group, is at carbon 2 when we count like this, and also at carbon 5 when we count like this. But when you count like this, it's at carbon 2 again, and also at carbon 5. So you can see that counting from both directions gave us the same number. Counting like this gave us 2 and 5. Counting like this gave us 2 and 5. You can see it now. 2 and 5. Okay, counting like this gave us 2 and 5. So you can see counting from any direction will give us the same number for the substituent. So we can simply pick any of the direction for counting. But in the previous example, it was not like that. Okay, one was shorter and the other was long. So we took the one that is lower to the substituent. So you can see here that we had methyl group at carbon 2 and another methyl group at carbon 5. Now, what becomes the name of this compound? You can see at carbon 2 we had a methyl group and at carbon 5 we had a methyl group. So the name of this compound becomes 2, 5. How many methyl? 2. So it will be dimethyl hexane. But we are not done yet. It must be noted that between numbers and numbers, we use the symbol comma, and between numbers and letter, we use hyphen, which is dash. So you can see that this is the name of this compound, 2,5-dimethyl hexane. So the next of the question here, you'll be solving it, and you provide the answer in the comment section below. Now, this is the question you'll be solving, and you provide the answer in the comment section below. Now, let's quickly move over to the next example. You can see here that this particular compound is an alkane, and this compound is an alkane, and at one of the carbon, we had a chlorine group. So whenever you see a chlorine group or any halogen, in this context chlorine, the name chlorine changes to chloro. Okay, so how do we number? First of all, we are to try and select the longest continuous chain. And it is very easy. This is the longest continuous chain of the compound, the longest continuous carbon chain. After doing that, you are to name the longest continuous carbon chain. Now, how many carbons are we having here? 1, 2, 3, 4, 5. So it means that the parent name will be pent, and since is an alkane, become pentane. Now, let's number the longest continuous carbon chain. So numbering from this direction, we are having 2 for the chloro group, and numbering from this direction, I think we'll be having 4, because 1, 2, 3, 4. So let's count from this direction: 1, 2, 3, 4, and 5. But numbering from this direction, which is 1, 2, 3, 4, and 5, you can see here that the chloro group here is now in carbon 4, which is not supposed to be so, because I said that the substance should be in the position so it has a very low number in the longest continuous chain. So this will not be the right answer. So let's quickly number in this fashion. This group is called the chloro group. So what becomes the name? It is at carbon 2. It becomes 2-chloropentane. Recall, between numbers and letter, you use the symbol hyphen or dash. Now, let's quickly move over to the last practice question. Now, you can see this question. This particular compound is an alkane because it contains single bonds. Now, let us try and identify the longest continuous chain. And in the look of things, it will be in the horizontal direction. Now, let's check. So, it's basically this. Because I'm seeing 7 carbons. 1, 2, 3, 4, 5, 6, 7. Now, if we are to count in this fashion, it will still be 7. 1, 2, 3, 4, 5, 6, 7. Okay? If we are counting from this direction, I think it will be 6. 1, 2, 3, 4, 5, 6. So this can't be the longest continuous chain, but this can be the longest continuous chain. But since it is horizontal, let's just work with the horizontal fashion. But it is not always in the horizontal fashion. There are other questions whereby you see that the longest continuous chain will not be in the horizontal fashion, but in another pattern. So let's say we are to count from this group. Now, looking at this group, we are having 2 carbons. So I cannot just count 1, 2. It will be 1, 2, 3, 4, 5, 6. Let's count like this. 1, 2, 3, 4, 5, 6. Now you can see I'm having 6 when I counted in this from this group. Okay, so it means that my longest continuous chain goes to this horizontal direction or this part. So let's just go with this. So after doing that, we are to name the longest continuous chain. Since we have been 7 carbon, the name of the compound becomes hept. And since the compound is an alkane, it becomes heptane. Now, let us identify our substituent group. Now, you can see the first substituent group here, which is CH3, which is called methyl group, okay? And the other substituent group here now is called an ethyl group. C2H5 is called an ethyl group. Recall, all of these are gotten from alkanes that lost 1 hydrogen. Now, this was ethane before, but removing 1 hydrogen from ethane, we got ethyl. Ethane is C2H6, but now we are now having ethyl group, which is C2H5. So that is for that about this particular substituent, which is the ethyl group substituent and the methyl group substituent. Now, we are to number. Which direction are we to number? Is it from this direction or from this direction? Now, in the look of things, numbering from this direction will be best. Okay, numbering from this direction will be best. So it becomes 1, 2, 3, 4, 5, 6, 7. Numbering from this direction will not be the best option because I'm having 1, 2, 3, 4, 5, and 6, and 7. Now, let's write the numbers we got from numbering from this direction. So it becomes something like this. For this CH3 group, I'm having 2 methyl. Okay, I'm having 3 methyl. And also I'm having 4 ethyl. These were the numbering from this direction. But let's check here. It becomes 4 ethyl, 5 methyl, and 6 methyl. So you calculating the values you are to get, it will be way higher than this particular value. Recall, I said that the substituent number should be very low as possible. So this can't be the numbers of the substituent, whereby this becomes the correct numbering of the substituent. Now, for we to add the substituent name to the parent name, these are the prefixes of this particular compound. Where are we to start from? We'll start alphabetically. E comes before M. So we write 4-ethyl first. So it becomes 4-ethyl. After writing 4-ethyl, we simply write 2. How many methyl groups? We have in 2 methyl groups. So it becomes 2,3-dimethyl heptane. Recall, between numbers and letters, we use hyphen. Between numbers and letters, we use hyphen or dash, whereby between numbers and numbers, we use comma, and between numbers and letter again, we use dash or hyphen. So you can see this is the name of this compound. 4-ethyl, 2,3-dimethyl heptane, because we are having a 2 methyl group in the compound. So if it was 3 methyl group, it will become trimethyl. So if you find this video helpful, do well to click the subscribe button and also share these videos with your friends. Thanks